Hello everyone, welcome to my presentation. I will present my work named CoScoreX. CoScoreX, a contextual and contestive framework for a stable post-hoc explanation in software defect prediction. So the first of all, the problem statement. Why developers don't trust AI debugging yet? As AI models can detect buggy code with high accuracy, but they are black boxes. Developers are left wondering why a file is flagged. Popular explainers like Lime, Shape, Breakdown to try to help, but they often give unstable and conflicting awareness. That is the main problem for this case. So, what is the motivation? Developers need more than just explanations, but developers have three pain points. One is instability, not actionable, and no context. That means the small changes in input lead to totally different results. Explanation don't tell how to fix the bug, and there is no awareness of similar code history. Developers need faithful, stable, and actionable explanations. That's why we develop a new framework called CoScoreX. It's a combination of context, contrast, and consistency. So the context, our learning from similar files, contrastive attributions, what would make a buggy file clean, and stability, our scoring, so results don't change unpredictably. That means for the case of existing Lime, it perturbs the input randomly, but for our developed framework, it goes through contextually, then find out the contrastiveness, and lastly it maintains the consistency. So this is the methodology that we followed to develop our framework. And the findings, we calculate the fidelity, and for the case of fidelity we find out that 60%, around 16% probability drop when we remove top k features, and that means it shows more faithful explanations. And we also calculate the stability, where we find out that 30 to 40% more stable across similar inputs. So it shows more consistency and less confusing. Also, we find out the inter-explainer agreement by using candle tau and cosine similarity. In both of the cases, we find out that CoScoreX performs better rather than other three explainers like Lime, Shape, and Breakdown. So, if we compare CoScoreX with other explainers, where we find out that local fidelity, global fairness, stability, contrastiveness, hybrid attribution, all of the features are present for CoScoreX, but not present in Lime, Shape, Breakdown. So the impact and takeaway, with CoScoreX, developers finally get explanation that they can trust, understand, and act on. That means that when developers use CoScoreX, they find out the trustworthiness. So the conclusion, our framework bridges the gap between the model fidelity and human interpretability, and that delivers the faithful, stable, and contrastive explanations. And it also represents a step toward human-aligned explainability in software engineering. So that's all from my side. Thank you, everyone.